There is a number that almost never existed. A number so bizarre that for centuries, people didn't consider it to be a number and referred to it with mere placeholders, or in some cases, completely deprived it of its notation. That's because for years, this number was thought to be non-existent, a statement that is partially true. 0 is a number we take for granted. It's a normal part of our everyday lives. The button on the calculator, the time on the clock, the indicator of a make or break on an exam. 0 is literally everywhere. But 0 is one of the most revolutionary ideas in the history of human thought, and it almost didn't happen at all. For countless centuries, many civilizations didn't have an official notation for 0 because they didn't think it was a number. The ancient Egyptians were the builders of the pyramids. They worked with the base 10 number system, they used fractions, and even did some advanced arithmetic. But they had no official number for 0. The closest they got was the hieroglyph Nefer, which was used as a reference point, but it was never considered a number. Another smart ancient civilization, the Babylonians, used a sexagesimal, or base 60, number system, which we still use by the way. Yet, for years, they notated 0 with a space, literally referring to 0 with nothing. This created some obvious problems, since two different numbers could be notated the same way. And what's more, they didn't think 0 was a number. The Greeks are another prominent civilization of antiquity that gave us geometry and logic. But like the Babylonians and Egyptians, they didn't consider 0 to be a number. To them, numbers measured quantities. How do you measure nothing? Even the Romans didn't recognize 0 to be a number. Their numerical system didn't even have a 0. Roman numerals are non-positional, meaning each character represents a fixed number, and there was no fixed notation for nothingness. Eventually, in the 7th century, a mathematician from India wrote down some rules for 0 as a number, which led to 0 being the number we have today. But who can blame the ancients for depriving 0 of its numerical rights? Take a moment to truly think about the idea of 0, the idea of nothingness. 0 is a mind-boggling concept. How can there truly be nothing? What is nothing? Can nothing even exist? Before we dive too deeply into a philosophical debate, you must realize that 0 is exactly what the Greeks of the olden days feared. 0 introduces a non-existent void. To the Greeks, this sounded unmathematical. But props to the Greeks because, to an extent, they were right. 0 can show strange behavior. For the most part, the behavior of 0 is reasonable. This isn't anything new to you. If you add nothing to something, or take away nothing from something, there's no change. If you multiply by 0, you get nothing because nothing of anything is nothing. But here's where 0 starts doing something strange. Notice in our equation here, c can be anything. 5, pi, a trillion. The equation still holds true. Normally, you would be able to solve for c algebraically. For example, if we wanted to solve for a here, we could divide both sides by 2. But when we try to isolate c, we get 0 over 0. That's indeterminate for the exact reason we mentioned earlier. C can be anything. There's no one answer. Think about it. How many times can nothing go into nothing? No times? Once? 5 times? Infinite times? The answer, it's indeterminate. But here's where things get even weirder. What happens if you divide by nothing? This leads to the renowned division by 0 error. Another way you could think about this is, what number can you multiply by 0 to get c? There's no such number. 0 over 0 has unlimited outcomes, and division by 0 has no outcomes. 0 is a finite, real number we work with every day, and yet it defies the orderly rules math uses for consistent results. But here's something interesting. Even though 0 represents nothing, solidifying it has laid a foundation for entire cores of mathematics. 0 unlocked the full power of the decimal system. It made negative numbers more meaningful in arithmetic. Computers are literally built on base 2, which just uses zeros and ones. Clearly, 0 is important, but that does not solve its mysterious behavior. 0 sits quietly as a normal part of our everyday lives. That calculator still has that button. The clock still ticks. But secretly, that little number holds the power to collapse an entire equation into meaninglessness. 0 represents the non-existent, and the number itself almost never existed, for good reasons. If you found 0 interesting, be sure to subscribe because there's another number that mathematicians wanted to deny, but couldn't.